Ladies and gentlemen, welcome to our webinar. Today, I am very pleased to have a very special guest in our webinar. But please let me introduce the concept of this event. Today, the webinar, it is dedicated to conservation and restoration of historical heritage on ancient architecture. The title is "Those with no past have no future," because we believe that our past, it is a very strong heritage for every future development. So in this case, we would like to propose a sort of discussion at the same level, at the same time, at the level of theories, approaches, but also in terms of technologies and methodologies of intervention. This webinar, it is organized by Zhejiang University, in detail College of Civil Engineering and Architecture, and our International Center of History, Critics of Architecture, and the Restoration of Historical Heritage, ICHCR. And today we are very happy to have three very, very important guests from Italy, which represent some of the most remarkable personality in the restoration and conservation of historical heritage in Italy. So it's a very big honor to introduce Professor Paolo Gasparoli from Polytechnic of Milan, Professor Lorenzo Jurina, also from Polytechnic of Milan, and Architetto Fabiana Pianezze, who cooperate with Polytechnic of Milan, and he's a very talented and young architect and very experienced in her work. The webinar, it is organized in two main phases. The first part, we will have a 20 minutes speech from the three guests, and then we will open a round table. And also, I'm very pleased to welcome architect Kong Yiqing and Professor Xuanjiang Hua, both from Hangzhou. Professor Xuan, it is from Zhejiang University, also College of Civil Engineering and Architecture, and architect Kong, it is Zhejiang University Design Institute, Ancient Architecture Institute, a very, very talented architect, professor with a very strong knowledge. So it will be a very good discussion. Now, few words about the idea of restoration. Restoration and conservation of ancient and historical heritage, it is a very important topic, especially in the recent years in China, because to restore architecture, it doesn't mean simply clean or recreate a sort of ancient past. The theory on the back, it's very complicated and very articulated. We have over 150 years of meditation on this topic. And we believe that it's very important for China to understand a different perspective from other countries. And I am Italian. My name is Paolo Vincenzo Genovese. My Chinese name is Luo Jiewei. I am professor in Zhejiang University in College of Civil Engineering and Architecture. And I am very proud to be Italian, because Italy has a very strong tradition and strong technology in the restoration of ancient architecture. But I don't want to take your time. And now I introduce Professor Paolo Gasparoli, who is our first speaker. His speech is entitled "From Restoration to Conservation: Objectives and Method of Intervention for the Preservation of the Material Texture of Historical Building to ensure the preservation of the data of identity and authenticity that make the building unique and unrepeatable." So thank you to Professor Paolo Gasparoli, who is one of the most prominent personality in the area of conservation of historical architecture. Very welcome, Professor Gasparoli. Thank you very much to be with us.
Thank you, you too. Good afternoon to everybody. Many thanks to Professor Genovese for inviting me to this meeting. and okay, share the presentation.
Do you see our screen?
Yes, it's perfect. Thank you very much.
Okay, thank you. So I start my presentation. I'm sorry about my poor English. And the subject of my speech is the project on built heritage between conservation and transformation, how to manage an inevitable change. I will develop the reasoning with three issues. The first one is why and what to preserve. I premise before we start, the topic from restoration to conservation is part of a lively debate in Italy since the mid-20th century, connected with the rise of the new discipline of the restoration of ancient monuments. This debate can be exemplified by two personalities and two opposing ideas. On one side, Viollet-le-Duc, a French architect, said that restoring means to bring the building, aged by time and use, to a level of stylistic perfection that is may never have had, which was in the architect's original intention. By contrast, John Ruskin, an Englishman, in his most important book, The Seven Lamps of Architecture, wrote that restoration is the worst form of building destruction because after restoration there is nothing authentic left. I lean very much toward this approach, and it is widely shared in Italy. The issue of authenticity is a really central topic, but why? Because Ruskin highlights the importance of identity and authenticity, which made the building unique and unrepeatable. Authenticity and identity are obtained by the preservation of the materiality of the architecture and the look that the building has assumed over time. So, in my opinion, there is also an aesthetic component that needs to be taken into consideration. Another great Italian scholar, Cesare Brandi, in the 1970s said, "You only restore the materiality of the work of art. So we don't restore the authenticity, the artisticity of a painting, but a materiality that make us perceive it." And from this point of view, the painting is as important as the canvas or the frame of that supports it. I think this is really interesting. Do you agree? I think. So we understand why conserve. We must conserve because historic buildings still tell us about past construction methods, technologies and materials, form of life, custom and tradition, and also indirectly give us some information about the societies that created them. And this can only be done with preserving the built material. So buildings are documents of the past, and these documents must be preserved and passed on the future with as much integrity, identity, and authenticity as possible, so that our children and grandchildren can have experience of them, can learn from them. By doing this, we are also preserving all the additions and layers that tell us about the transformation that the building has undergone over time, which make them a real palimpsest to be studied and investigated. In this slide, you can see the Cathedral of Syracuse in Sicily, a fantastic example about it. the Greek temple became a Christian church, and over the centuries, chapels were added with the different styles. The different expressions, the differences in style, represent a wealth of information about the building, and it would be a nonsense to bring it back to its originality. Indeed, the history of restoration is also the history of the transformation that buildings have undergone over time. So it does not matter if these additions are not coherent, if they are bringing together different styles and languages, and this is exactly the interesting thing. Preserving is a moral obligation, because anything that, for whatever reason we destroy, is destroyed forever. So the second issue is how to conserve. We discussed the importance of preserving the material. Building agents bear on themselves the sign of the passage of the time. The wrinkles of time are written on masonry, plasters, and stones. These signs are not only signs of degradation, but signs of authenticity, like the defect in an old piece of furniture or the frame of an old painting. So the first problem is to accept that decay is basically a natural phenomenon and is not a priority problem for an old building. All things age. As a result, we must focus on keeping the building alive with constant activities that can prevent or control degradation phenomena related to environment progression and usage. In my view, it is methodologically incorrect to replace the building's part, like roofs, plasters, decorative elements, unless they are totally damaged. Example, they can no longer be preserved because they no longer be to carry out their function. However, if the degradation is very advanced, it means that the necessary conservation and maintenance works has not been done before. So, planned maintenance and preservation are another issue that needs to be investigated and addressed. Just to touch on this topic briefly, the techniques that are used for conservation works on masonry, stones and plasters, in particular on surfaces that are the things I best know, are cleaning, consolidating and protecting surfaces. In this slide, you can see ways of consolidating plasters with mechanical fixing. In this slide, example of laser systems which are very effective and very gentle on the surfaces. Here again, different wet or dry air abrasive cleaning systems, consolidation or reaggregation with primers to restore texture to decohesive and pulverizing materials, and then protective intervention with waterproofing products to make environmental degradation agent act less aggressive, like water, frost, wind, humidity, etc. Finally, intervention for the restoration of decorated surfaces, stuccos, frescoes, gilding, etc. In general, we know very well how to do it. In the last 50 years, very efficient restoration methods have been developed in Italy to really guarantee the preservation of the material. On structural intervention masonry, Professor Jurina will talk about that. So we understood why we needed to preserve the material of historic architecture, and I gave you an overview of the main techniques for doing that. However, there is a problem. Buildings are object of use. If they are not used, buildings decay very quickly, but we know that the needs of the users are always evolving, and therefore building, in order not to be abandoned or destroyed, must be able to adapt to the changing needs of their users and their community. Perhaps it would be better to say that we ought to have the ability to make building evolve according to the changing needs of the users, according to compatibility criteria. And this, the third issue, use, reuse, and compatibility. How building evolve, how historic building evolve is another real issue. We said that it is a priority to preserve the matter of architecture, but now we are saying that buildings must also transform themselves to adapt to the needs of their users. So it is likely that we have to sacrifice some substance of which architecture is made. There is a conceptual, a practical clash between the preservation needs and the transformation needs. How can this struggle be managed? In other words, how to decide what to preserve and what to transform? I think it is necessary to have a roadmap for regulating inevitable transformation, and this roadmap is called performance approach. Let us see what it means. First, we have to start with a deep knowledge of the building, its history, the transformation it has undergone, its state of conservation, and the utilities it can still give from a functional point of view. We call this diagnosis. We start from the idea that a building always offers a performance, even if it is an advanced state of decay. So, on one hand, through a proper diagnostic activity, we must assess the performance that the building is still able to offer. On the other hand, we have to assess the needs of the users through the analysis of their activities and set the spatial and the technological requirements related to their new activities. Of course, the levels of the performance offered is also influenced by the state of preservation. So, in the event of a correspondence between the performance offered and the requirement, we will have preservation activities. In the event of major differences between the requirements and the performance offered, we will have to undertake improvement, upgrading activities. This seems the correct way to approach the problem of what to conserve and what eventually to transform, making decisions based on rational choices, not on prejudice. I mean judgments defined previously. Managing necessary change of historic buildings means verify to compatibility of the activities for which we are used. Not all buildings are able to host any function without being damaged. Some buildings can accommodate some activities, particularly those compatible with their shape, structure, and spatial constitution, others not. This is another problem to focus on. If it is unavoidable that building should evolve with societies, the project should facilitate a slow metamorphosis rather than a radical change that would distort the building, and so its identity would be denied or greatly damaged. We said that in the case of the reuse of an existing building, especially if it is an historic building, the project must aim at determining what we preserved and what needs to be transformed to meet the changing needs. This must be done according to the outcomes of the analytical phase, based on the different values represented that are evaluated in different ways. In some buildings, the cultural value will be higher. In others, the user value will be higher. However, it must be considered that some performance gaps in an old building can also be accepted to allow the benefit of other qualities, which only old buildings have, such as historical, cultural, or aesthetic values. It will be possible to verify through the settlement of appropriate and compatible function, new structural, distributive, formal, and material arrangement within a framework or respect of the existing heritage. Such arrangement will be able to take shape as a sign of the contemporary. In this slide, you can see some example. And we allow the overlapping and transmissions on experience and knowledge across generation. The intervention of reuse and transformation involves addition that must dialogue with architectural, historic architecture. Here, another aspect is raised that involves the issue of compatibility, but which we do not have time to develop now. Thank you very much.
Thank you very much, Professor Gasparoli. Very kind of you, very interesting, and your work is really remarkable, both for methodology, approach, and the quality. All the buildings that you show us are your work, and I'm very curious to know more in the future. So when I'm in Italy, please bring me to the different building site. I will be very happy to see you around.
Thank you.
The next speaker is Professor Lorenzo Jurina, and he is a very special personality to me because he was my professor of structural engineering in Polytechnic of Milan some years ago. So I'm very happy to have my professor with us today. His speech, it is an illustration of some cases of consolidation of historic building, practical cases analysis. Professor Jurina, the floor is yours. Thank you very much to be with us.
Thank you so much. Well, really, thank you so much to Professor Genovese and his university to invite me to the webinar. And thank you very much to the people that will assist to this presentation. I will be very, very rapid in my things that I will tell you, because there are a lot of things to tell, and 22 minutes are few. And I'm an engineer, a structural engineer, but I'm working with architects since a lot of years, 44 years, and I like to work with them. Really, they are. It was a very, very, very interesting experience for me, and I'm very, very lucky in the sense that condividiamo questo schermo. Vediamo un po'. Eccolo qui, te. Yes. And some experience that I will tell you. And I tell you that I'm very lucky because I was, I've worked with a lot of beautiful things, like these castles, for example, in Pavia, in Vigevano, in Masino, in Armenia, in Cremona, again in Cremona, the church near Milan. Wonderful places really to work on this in Armenia again. And this, well, of course, it is Venice, the church of San Marco, the church of Salute in San Marco, all works in which I give part of my experience and of my work. And also some towers, for example, these towers in Pavia that needs to be consolidated. It is a tomb in Algeria, some palaces, very, very, very nice and interesting palaces. This was my first job in 1978 with Professor Marco De Zibardeschi. Yeah, I started with that. And some other wonderful palaces. This is the Gallery of Milan, and well, and in every one of these cases, due to the help of my friends and teachers, I try to remember some simple words. One of these is respect. Respect for the thing, respect for the beauty, respect for the history, respect for the materials also. So I tried to make my work of a structural engineer, trying to give safety to the buildings with addition and not demolition, with light structure, efficient structure, possibly not invasive structure, reversible and active structures. This is one of the things that I've tried to do in my work, saving authenticity of the building, and just in case of real need. It is wonderful when you can tell after diagnosis that there is no need to do nothing in the structure. Wonderful thing. And if possible, with some elegance, why not? Yeah. And I will show you some short flash of my experience. Starting with this Palace Stradiotti in Cremona, the situation was that, very, very beginning with that. Well, as you can see, the skin is very bad, and the situation was that. Now, a new use, an academy, music academy, will be certainly in that, with a lot of grants for students. A lot of Chinese people will come there to study viola, violino, and violoncello. And some things, these beams and these, again, beams, and with fires and so on and so on. So a lot of bad things. And, well, a plan of these, and a lot of bolts. And so we've studied a system that is the use of these small triangular wallets, these triangular wallets that have demonstrated in masonry, that have demonstrated to be a good, interesting, and respectful experience and satisfactory solution for the safety and the stiffness of all the bolts, as numerical analysis has demonstrated in a lot of cases. And these are the wallets, the triangular wallets, with some FRP elements over there, masonry and tension resisting elements working together with the original masonry of the walls. And of course, some other intervention related to beams, of course, like that, very simple mixed system with concrete and beam, and the system applied also in zone where there are void. So I've used a sort of triangular girder like that, in which these elements have been left at the view, because in that way the beam works very, very, in a very good way. And remembering that in every case you have to hang your element to the walls to obtain a good seismic resistance, like that. And in other cases, I've inserted tendons or cables to help the bolts not to push too much. And again, cables in the stairs like that. For example, the stairs were very weak. And so I hanged them to the top with these cables and connecting these to these beams. And so saving the possibility to have the old beams and the new safety so that this school, this academy can work without any kind of problems. And here also the furniture have been studied with Pininfarina, and well, the results are really interesting. For example, in that case is noise control, well, as there is music in every one of the rooms. Now the final solution is that, well, after restoration of the painting and so on, and the final situation is this and that. And so the people can play happily in a place like that. And so the final situation of the facade is, well, a little bit different from the second example will be Villa Simonetta in Albania. This one in place a map here, a laser scanner view of this beam. Here we have worked with Professor Gasparoli last year, really. And well, again, the situation was not really said. And you see, 35 years of no use means this kind of consequence. And the roof is collapsed. And so the people, the owners, the major thought that there was no possibility to save the house, the palace. Look at that. This is the inside situation, the walls, and well, look at the paintings in which bad situation they are, and the stairs also. Well, with a lot of things of waste over there and over there. And again, a problem of safety. This big vault was pushing against the wall, and so we decided to introduce not a lot, but some cables to avoid this movement, to resist and to stitch these cracks. And the use of a system that is a RAM system, reinforced arch method, that I have invented some years ago, and that is a very, very old idea, this one. That means that I try to join the different pieces of wood without glue, without any things, but obliging the different bricks to work in compression one against the other. This is the situation. I want that they work in compression, one against the other. And the criteria is to apply new forces, to move the truss line nearer the axis of the arch. This is the idea. The idea that can be obtained inserting cables or outside or inside the arch or the vault. Some models in which we see the point of the cracks, the pins with a mechanism of 4 inches, and if you add a cable and you apply forces here, what will you obtain? Radial forces applied, like in the barrel that I've shown you before, applied to all the arch. I've done a lot of experience, real experience, in which the confrontation between plain arches, reinforced concrete with a layer of concrete over there, and the RAM system have been compared. And the results are very interesting. Unreinforced arch, 100, 200 kilos was the resistance. RAM system and also the concrete, 2,000 and so more kilos, so 20 times more. Very, very interesting. But RAM system is more respectful. I don't apply new loads. The system is light, the system is reversible, the system is active, and so why not to use RAM system? And I've done a lot of small example in which we can prove that external cables or internal cables work at the same system. Look at that. This is the response without cables, and this is the collapse load that increase incredibly when you increase the force in the cable. Really, 10, 20 times more with respect to the original situation. And this system can be applied to all the possible curved surfaces. There's some recent application, for example, in this palace in Varese, with this cable that are applied along the principal, the diagonal, the principal arches hidden inside the vaults like that. like that. Well, the different kind of bolts need different elements. And for example, look at there, here in this situation, well, external cables applied externally, like there, like here, this sort of a star, and again in that. But in some cases when I couldn't remove this part because the floor was beautiful, I was obliged to choose internal elements in which these tendons apply forces that comes from outside to inside, so applying the same system of forces to the arch. And we obtained in this villa, in this palace, solutions like that. Well, the cables are visible, the cables are apparent, but they try to follow the principal arches of the bolts, like we can see here, we can see here. And how to apply the forces here at the basis, we find elements like that in which a nut here can be used to apply the forces. Well, another example of internal arches in another palace is that stainless steel elements that can apply the forces. And in the same palace, in a case where I could not apply cables neither outside, neither inside, I've used a structural lamp. The structural lamp is that the was there. This is the lamp, and this is you see the lamp, and these are props that are trying to sustain the volts. Here it is. Yeah, here's the structural lamp and the props, a compressed element that help the volts to be resisted. Here we have. And also in the stair, we have done something. The situation, the stairs was very dangerous, like that. And well, now the situation was saved, adding this L-shaped element that can help the stone and of course the handrail also to resist the forces, applied forces, and satisfy the norm, the regulation, and so on. And this is the situation of the volts that we have done. Remember, this was the original situation. This is the situation now. Yeah, and so well, we were very happy of these results. And also some things, the external facade, and so. Well, some other examples. Yeah, I have 6-7 minutes more. Trezzo d'Adda castle. This is the castle in Trezzo d'Adda. I worked in the tower and in that wall. And the one there is a sketch of Leonardo da Vinci that was living there for some years. Well, there was this wall, a very slender wall, a very dangerous wall. And well, this was the wall with these small holes. What have I done? I have inserted some safety cable stays. These are the elements, like that. You know, these are cables with which I have well helped on one side, and on the other side of the wall, I have avoided the rocking of the element. Well, some details. And again, on the tower had a big crack over there, and so I decided to stitch the element like that, inserting stainless steel cable in this, well, here in that situation, as you can see. And well, this was the structural intervention, but with very comfortable scaffolding. The people there, the owners, asked me to insert a new stair, not this dangerous stair, but a new stair with this crane, inserting pieces of the stairs starting from the top, because ministry asked me not to make neither one hole in the masonry. And so I built this stair, you know, it is a Corten steel tower, inserting two beams in the top and some cables coming down from the top. So the stair is an angled stair, you know, the cable comes from the bases, and this is the elements of the Corten elements of the stair coming on, and permitting us to make a sort of promenade to the top of the tower, looking at what we can see. And the tower is of the 13th centuries, very noble. and this is on the top of the tower. And another tower in Milan, Torre Guarani, this tower was abandoned after the Second World War. In this situation, a medieval plus 17th century addition, scaffolding, very old, very bad one for 30 years. And they asked me to make a new structural stair leading me to the top of the tower to see over there. And I've built a very strange stair that is that with 5 blue columns going from the top to the basis to the top, in which the stair can be connected and reaching the top from where you can see a wonderful landscape. This is the construction, the transportation in the night, and the movement of these, the insertion of the different segments, and this is at the end the structure that you can see. Very, very not usual structure, very transparent structure, in which the blue columns and these cables offer a coefficient, strong coefficient of safety to the tower. So not a beauty or an elegant or something like that tower, but also a structural tower, because it is my work. Yeah, and I want to work with the component. And at the end, the tower is there. Abbazia di Chiaravalle, a church, 13th centuries, again, in which you have this tower, very, very beautiful tower with a lot of windows. Yeah, the problem is that a lot of windows. And so the finite element model told me that it is dangerous. And so I've decided to insert something that you in China probably know very well. And it is this, an hyper made by cables. And so I've inserted, and the works are in this moment in execution, I've inserted a structural hyper working as diagonal stays in this way. And so, of course, what will you think? Something like a cantilever truss girder that don't move and that give us strong help in terms of safety, in terms of another example, the Duomo of Cremona. The most easy solution would be to do that, but they didn't let me do that because the situation was so beautiful that no cable was possible. And so I decided to operate from outside, like in that way. So pulling, applying forces from external. Look at that. Yeah, look at that. Yeah, look at this element. These elements are applying forces to the bolts so that the bolts cannot move. Yeah, and so the situation is that, and people can move over there in a place where nobody was used to go since centuries. Yeah, and so this is the situation. And another tower, the medieval tower, in which a much more interesting example. This was an example with a friend that is Luca Gelmini, or sorry, the other friends were Eduardo Elli and Paola Sani from the other cases. Well, in these cases, working with Luca, we have inserted a structural stair inside the element that is that, but permitting the two languages, the language of the stones and at the same time the language of the steel working together with a sort of very clear differentiation about the things. That is that. And well, the final result is that. 6 photos from Pompeii, in which I worked a lot in these last years with cable again. The columns are dangerous. The columns try to go down. And so I've inserted some cables to permit the people to walk in that zone that were closed due to safety. So the situation is that. And so a sort of constraint applied to the top of the columns so that they will not collapse again. Well, of course, my work is a continuous game with the structure, again with my friends, again with my the people that work with me, and some wise. Sometimes we have to learn from games. Like in spaghetti bridge competition, I like very much to do this kind of works or games in which people understand how the things collapse and how the things work, like that. Yeah, bridges and so on made by spaghetti with the competition with my students. Well, the students in some cases are very in a very difficult situation. And at the end, well, it is interesting to see also the collapse of these elements, because from the collapse, you can understand a lot of things. And so please, let us hope that our structure will not collapse, but well, we have to understand something also from this. And so with this, thank you very, very much for your kind attention, and you can find some more information on my site. Thank you very much, and good work to my colleagues, engineers and architects.
Thank you very much, Professor Jurina. And I come back maybe 30 years ago when I was your student, and I have the same feeling and the same joy to listen to your lesson. It is very, very impressive. And I remember very well when Professor Jurina always insists to work with tension instead of compression, because it's more elegant and it is very, very flexible. Thank you very much for your wonderful experience. We will have more comments at the end during the round table. The third and last speaker is architect Fabiana Pianezze with a speech on the restoration project from survey to construction side. Please put much attention on this young and talented architect, because she will surprise us with a very interesting works. Thank you very much to be with us.
Thank you.
The floor is
so much
yours.
to you. Thank you. I'll try to share my screen. Okay. Here we are. Okay. Okay. Good afternoon, everybody. I'm very, very pleased to be here with you today. And as anticipated, my presentation is about the process to be followed in developing a restoration project from survey to site. We have seen through the presentation of professor before me that the key issue when we deal with when working on build heritage center around the question what to conserve and what to transform. The answer depends on the set of values we are able to recognize in building and meaning we attach to the words identity, authenticity, and compatibility. Conservation, as defined by the culture of restoration and by the laws regulating the field, is aimed at preserving memory, is based on the awareness of the value of historical material, and is based on the importance of transmitting that material to the future. From this point of view, however, it's essential to know exactly the building and its context before intervening. So how do we build this knowledge is the center of the question. At the root of knowledge, there must always be the awareness of knowing that we don't know. What does this mean? It means looking at the built heritage, aware that we are bearer of values that are products of our time, and knowing that there are many things that our eyes are not able to see, either because we lack the tools to understand that information or because we are distracted by other issues. I brought you an example to make you understand how our attention is only able to focus on certain aspects and we are not always able to see the whole of reality. I don't know if any of you are already familiar with this experiment on selective attention, which was created in the 90s by two Harvard psychologists. Anyway, let's watch it together. I think it's really, really interesting.
This is a test of selective attention. Count how many times the players wearing white pass the basketball. How many passes did you count? The correct answer is 15 passes. But did you see the gorilla?
Okay, when I saw the experiment for the first time, it was amazing for me to realize that the gorilla was on screen for more than 9 seconds. Okay. So now it's quite clear that we are missing a lot of what goes around us and that we have no idea that we are missing so much. It's therefore the responsibility of each of us to keep ourselves with the necessary tool to read, understand, and interpret the built heritage with its signs, its contradiction, and its stratification. And this is achieved by accepting that our judgment is not universal, and only through constant study we can train our sight. But if we are talking about a specific building, how is the knowledge built? This is possible through different activities. On one end, information activities, that is the search for bibliographic, cadastral, documentary information. On the other hand, field survey activities. In addition to this indirect knowledge activity, we can carry out the direct activities on the building. Let's take a quick look of each of them one by one. When we build a restoration project, the first indispensable step is to analyze the historical documentation at our disposal. From archival records, maps, or written documents, we can understand the building's evolving history and obtain the first keys to interpreting and understanding it. The next step is to carry out the building survey. This may seem to be an activity of secondary importance, but on the contrary, it will be valuable if historical information is lacking. In fact, the building itself can be considered a document from which useful data can be obtained. Once the graphic basis has been built up, the diagnostic activity can begin. This is carried out, first of all, through visual analysis, for which it's necessary to have the trained gaze mentioned earlier. The first activity to be done is to identify the materials in place and report their quantity and extent on a dedicated graphic table. Secondly, the degradation on each material are identified. It's clear that at this stage, in addition to analyzing the visible phenomena, it's essential to try to understand what may be causes that triggered those phenomena. Diagnostic intervention are the second level of inquiry and give more detailed information on the composition of materials and technological characteristics of the building. These investigations involve specialized laboratories and are usually minimally invasive for buildings. This is the moment in which not only the skills of the surveyor intervene, but science is placed at the service of knowledge. In order to further investigate, it is often necessary to carry out stratigraphic inquiry so that we can understand if there are hidden layers beneath the surface, or we can carry out soundings which provide a better understanding of how structures and technological nodes are built. If possible, it would also be advisable to carry out tests on the surfaces, because it's true that intervention procedures follow well-established practices, but it's also true that the same methods must be calibrated on a case-by-case approach, verifying application times, production dilution, intensity of action, detailed operating method, and so on and so on. We have therefore seen how to construct knowledge of the building, but we also know that buildings are objects of use. It's therefore necessary to understand who the users are, what their needs are, and the patterns of using spaces, as already said by Professor Gasparoli before me. To do this, and to define better how to develop the restoration project, we have to do well-known investigation and diagnosis procedures that are more generally known as activity analysis. These activities allow us to specify in detail all the aspects listed above about users and compatibility between user, building, activities, function, and so on. The ultimate goal is always to guide the project choices, make the necessary compatibility evaluations, and define what to conserve, how to preserve the historical material, and if necessary, what to transform and how to renew the building. And all this is done accepting that when dealing with the historical building, it may be necessary to completely redesign the whole project because intervention will not be compatible with the building itself. The intervention project on built heritage has to manage all areas of work, from surfacing and facade to structures and installations. To do this, it's necessary to involve sector experts who must work side by side so that the project is truly effective and guarantees compatibility at all levels. Once the design phase is completed, the authorization process begins. It's not important now to go into detail, but it was interesting to make you realize that it can take up several months before the activities can be transferred to the construction site, especially if additions to the project are requested by different supervisory bodies. The slide shows an example of a church which, as a listed building, has obtained 3 different levels of authorization before the building site can be started. Authorization by the municipality, authorization by the curia, and authorization by the superintendency. And then, at this point of the process, the construction site can begin. Again, each location has its own specificities and difficulties, which may be logistical, climatic, organizational, etc. One of the most interesting aspects of working on built heritage is that the knowledge process does not end at the design stage, but valuable information is derived from the construction site. This new information enhances the knowledge initially possessed and increase the tools that are part of our mental toolboxes. It's precisely this information that must not be lost and should be included in a document that is known as a scientific final report. It represents the last phase of the knowledge and restoration process and the premise for the building future maintenance program. The scientific final report collects the results achieved and the complete graphic and photographic documentation of the state of the building before, during, and after the intervention. The construction site is also an opportunity to test new technologies, such as BAI modeling, which unfortunately is often misused in the built heritage field. During the construction site, advanced tools can also be used, for instance, to remotely control the operation carried out on the scaffoldings. With technologies of this kind, the time and thus also costs required for supervising operators could be surely reduced. And to finish, we can say that through participative site management, it's also possible to involve the population, spreading awareness and increasing citizens' affection for their heritage. This is a fundamental aspect in the field of conservation and field of heritage and historic architecture, because as people wiser than me said, we can only preserve that we hold dearly and which we recognize as an essential part of our values. This means taking care of our past and with it of our future as well. Thank you. I've already finished.
Thank you very much, Architetto Pianezze. Very interesting presentation with a very solid and clear method of investigation. I want to remark that all the pictures that you have seen today, they are professional job. They are not a reference picture. And this is very important and give you the magnitude of the 3 great architect and professor who are here today. So it's a really, really important experience. Thank you very much for your speech. And now it's the time for the round table. And I wish to invite Professor Xuanjian Hua and architect Kong Yiqing to take a part on our discussion. So if Professor Xuan is ready, I would like to give you the floor and comment the work that we have seen right now. Professor Xuan, the floor is yours. Thank you very much to be with us. And I want to also remark that Professor Xuan is a member of our international center. Thank you very much to join in our research, in our work. Thank you.
Thank you, Professor Paolo. It's very pleasure to come here to join the meeting. I learn a lot from the Italian professors and architects about the conservation, and it's very remarkable projects they have done, and some very advanced techniques in survey and treatment of the old buildings. So it's very interesting and impressive to me. Talking about the restoration, we have done some projects in China. The procedure seems similar with Italian pharaohs. But the structure is very different. You know, the Chinese old buildings made by wood structure is very special. It's different from the brick and the stones. Yeah, it's very interesting to see that the Professor Jurina cable techniques in the structure consolidations. I think there it's helpful maybe in the future in China need wood buildings consolidations. Thank you, Professor. Yeah, it's my comment. It's okay. Thank you.
Thank you very much, Professor Xuan. And please, Architect Kong, if you would like to give your comments on today, we are very happy to have you with us. Thank you so much. The floor is yours.
Thank you. Thank you, Professor Genovese, and very impressive work from Polytechnic Milan on sharing the fantastic restoration of heritage buildings in Italy. As Professor Gasparoli mentioned, heritage face inevitable change such as nature decay. And in other way, heritage is also unrenewable and irreplaceable assets. Heritage buildings are historical records and tangible expression of cultural identity and diversity. So when we carry out restoration or reuse work, we must use appropriate and sensible methods to avoid or minimize adverse effects or unexpected consequences. And these are all did very well in the examples and case studies by the three experts from Italy. As Professor Jurina mentioned, the language used by new additional parts, the dialogue between the original and new parts. I remember that in Venice Charter, it claims a very similar thing, that the replacement of missing parts or new additional must be integrated harmoniously with the whole, but at the same time must be distinguishable from the original, so that restoration or the reuse does not falsify the artistic or historic evidence. And I have learned from the case studies by Professor Gasparoli and Professor Jurina. They use very careful methods to restore for the restoration of ancient plasters and very careful methods for the arches reinforced experiments. Finally, I totally agree with the architect pioneers. The heritage significance is the essential thing we must conserve and enhance in any heritage work. In my opinion, we are not heritage owners. We are heritage keepers. We conserve what we valued, then take our responsibility to retain heritage authenticity and integrity, then pass on to future generations. This is a way towards sustainable heritage. So I have learned this from the three experts. Then thank you, Professor Genovese.
Thank you very much for your comments, very pertinent. And now is my turn to give the final remarks on this webinar. I want to start with a very famous Italian from the past, Enrico Mattei, who was the president of ENI, the National Energy Agency of Italy. And Enrico Mattei, in the past, in his biography, said, we Italian, we are a small nation, but the world will remember us. And this is true. We are just 56 million of people, which is probably a couple of big cities in China. But our work as Italian is always special, shall we say, with the style of work of Italian is basically impossible to copy because it is very chaotic during the process, but then finally some masterpiece come out. And this is exactly the case of the examples that we have seen. You have no imagination how complex and how difficult it is to create such work of restoration because of the public administration in Italy are very complicated. The bureaucracy, it is a kind of cubist composition. There is no logic in the bureaucracy of Italy. So the process is quite complicated. But from the side of the process of restoration and conservation in Italy, there is one big advantage. And in my personal point of view, the great point, it is the philosophical approach, the method, the investigation of how to do and especially why. It is not a case that when we opened this center, international center here in the College of Civil Engineering, I insist a lot about one word, which is a critics of architecture. So the critical approach, it is probably one of the most important element, because we must understand why we have to do such kind of intervention and all the philosophical and methodological components. Professor Jurina, during his speech, quote a very important architect, who is Marco Dezzi Bardeschi, who is also my professor, and finally we become good friend. Unfortunately, now he is not with us anymore. His theory, it is one of the most important, could be controversial, could be, there are several different proposals on the table concerning the approach of restoration. But what he stressed a lot, it is the complexity of the investigation of the past and the investigation of the ancient building. Without a theory, the practice means really few. So this is what Italy probably could teach to the world. And what I also consider very important in the historical preservation in China and in every nation of the world, it is related on the identity of a nation. This is probably a sensitive issue, but it's too important to mention. Because if a nation, doesn't matter which one, doesn't have no consciousness about the past, that is quite critical, because it is not a case that China and Italy are two nations with some of the most remarkable historical tradition. And exactly for this heritage, exactly for this great value from the past, we have to mention, we have to understand what the past means for us, because it's too important to preserve for the future. This is why the title of our conference today, it put the relationship in between the past and present. And there is no possible future without the consciousness of the past. Now, the material aspect of this element, the buildings, but not only the building itself, but also the natural landscape or the city itself, it is the material aspect of this history, and teach us day by day what it was and what is our mental mindset, mental process, because the history is too important to be changed. Some research are ongoing. I think the proposal from Italian, and in particular from Professor Gasparoli, Professor Jurina, Architetto Pianezze, are, to me, quite important statement. We have seen some building which is extremely important in terms of quality from the past, and also important because we have seen also the Galleria Vittorio Emanuele in Milano, or some important church in Cremona, and so on, that are masterpieces from the past. And the future generation will learn not only how beautiful is it, because I should remind that from the past, the architecture, it is not only a beautiful toy, a beautiful piece of art, but it is always an element of transmission of idea. It is a book, it is a sort of text which transmits a message. If we lost that message, then we lost some important voice from the past. So this is there is something more to say, but I won't keep it simple. And I am very pleased to have all our guests here with us. And I formally invite you to visit China. Now, China is open. You can come to visit us. And I wish not only to have you here for a lecture, but also to show you around and how beautiful is the historical heritage of Hangzhou and in China in general. So thank you very much. And to every one of you, thank you to be with us. Thank you to Professor Gasparoli, to Professor Jurina, to Architetto Pianezze, to Professor Xuan, to Professor Kong, to Architect Kong. And I also want thanks to all my team who make it this webinar happen. First of all, our partner, our media partner, who is Archidogs, who are not only partner but also good friend, and they do a remarkable job to support to technically support our webinar. And then I want also thanks Sharon, my PhD candidate, and Chibesa Kalinso from Zambia, Liu Winnie from Taiwan, and also Miss Jin, who is not with us, but she always help us, and Wu Hong, also my PhD candidate. All of them give a very strong support to our webinar. So thank you very much, and I really wish to see you here in China, and definitely we will meet in Italy when I come back to my hometown. Thank you so much to be with us.
Bye bye. Thank you.
Thank you. Bye bye.
Thank you.
We'll see you again. Thank you so much.
See you soon.
See you.
Well, just one word.
Yes.
The system of cables, speaking about wooden structures or timber structures, have been widely used also in that case. Because, for example, roofs of many churches and other palaces have been helped a lot trying to, well, transferring the concentrated loads from one point to other points through cables, exactly. And so the system can be really, with some tricks, applied not only to masonry or to stone elements, but also to other elements. Of course, wooden elements are elements that are with the phenomenon of creep. And so applying cables, applying forces and so on has to be done with a certain, with carefully, in the sense that every half year you have to go there and to stress again the cable for the first half year, the second year, and after 5 years, and so on, because you have to be sure that the cable do their job. But really, the system can be applied to a lot of different solutions. Thank you very much for your observation, Professor.
Thank you. Thank you, Professor Jurina. Thank
Yeah.
you. Thank you so much.
Well, see you.
See you very soon. Thank you. See you
See you.
again. Thank you. Thank you very
Thank you.
much.
Bye.
Thank you.
Bye.
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 Bye-bye.